Okay, so this lesson 3.2 is on intercepts and standard form. So we're gonna just look at the equation that we're gonna be working with. We've talked about slope-intercept form, which is y equals mx plus b. And we've learned that when we graph a line using slope-intercept, we plot a point at the y-intercept, which is the b. And then we graph the slope using rise over run. Now, we're gonna learn a different way to graph a line using a different equation. And this equation is called standard form. And it's in the form of ax plus by equals c, where a, b, and c are constants. We typically know a and b as coefficients, but in this case, they're constants, and x and y are our variables. Our x and y stay x and y, but our a, b, and c will be numbers. Okay, they will have values to them. And so we could have an equation that's 2x plus 3y equals c, where 2 would be your a, 3 would be your y, and what did I say c was? 2x plus 3y equals 4. We'll say c is 4. Bless you. And you will use this equation to find your x and your y intercepts. And remember, how many points do we need to graph a line? 2. So if we have our x-intercept, like this one right here, and we have our y-intercept, like this one right here, we can graph a line, because all we need are 2 points. And so over here, we have our x-intercept, where x is some number, but y is 0. So what is the x-intercept on our graph right here? Can somebody tell me? 2. Yes, our x-intercept is 2, and you would write it as 2, 0. Okay. If you look at our y-intercept, x is 0 and y is a number. So in this case, our y-intercept is 0, 2. Okay. And we can get these two pieces of information using this formula. Now, we can get the y-intercept using the slope-intercept formula, but we can't really get the x-intercept using that one. So we use the standard form of an equation. So let's go down and look at some vocabulary. Oh, you're right. The x-intercept is -2. Thank you. Thank you, Parker. All right, so let's look at some vocabulary. The points at which the line crosses the axes. And when you say more than one axis, it's axes. And so those would be your intercepts. Okay. A point on a line that crosses the x-axis would be your x-intercept. So where it crosses the x-axis, you have the x-intercept, and a point that crosses the y-axis would be the y-intercept. Yep. Okay. What is this equation called? Y equals mx plus b. Slope intercept. Now, do you guys know why it's called a slope intercept? Because m is your slope and b is your y-intercept. Slope intercept. So slope intercept. And I'm going to abbreviate that. So over here, you're just going to write slope intercept. Okay. Now, this one we're learning today is called standard form. Okay. And then after this lesson in the future, you You can choose whichever equation you want to graph on. Okay. All right, let's go to page 2. On page 2, we are going to identify the correct way to write an equation in standard form. And there are 4 criteria. Okay, so not all equations are written in slope-intercept form, such as y equals negative 2x plus 5. Sometimes it can be written, or we can express it in standard form, such as 2x plus y equals 5. And so that's what we're going to learn. So in order for equations to be written in standard form, they must meet 4 requirements. Both variable terms should be on the left side. What does that mean? That means your x and your y terms need to be on the left, and the constant term is on the right. That's different from slope-intercept, where y is on the left and your x variable term is on the right. The constants in the equation a, b, and c should not be fractions or decimals. So no fractions or decimals in the equation. There should not be any common factors shared by 3 constants. So for example, if we had 2, 4, and 6 in the equation, that is not in simplified form. We would have to simplify that, and I'll show you how to do that. And then the coefficient a, where the 2 is up here, must be positive. It cannot be negative. And if it is, we have to change it. So when you see an equation that does not meet one of those 4 requirements, we have to change it. And so we're going to go through this and do that. So let's look at the first one. All these equations are not in standard form. This is why, and then we're going to change it. Okay. So let's look at this one. Y equals negative 3x plus 5. This one is not in standard form. It's in slope-intercept form. It can't be in slope-intercept form. So we're going to rearrange this equation into standard form. That means that both the variable term y, 1y, and the variable term negative 3x must be on the left. So we're going to move the negative 3x over. Okay. And you now have 3x plus y equals 5. And your x comes before your x variable term comes before your y variable term. And so then now all my numbers are positive. There's no fractions or decimals. Both variable terms are on the left, and a is positive. So this one is correct. And there's no common factor between all of them. Okay, let's look at the next one. 1/2 x plus y equals 5. Okay, there's an issue with this one. There's a fraction. All your constants must be integers. This is not an integer. Remember, integers are positive and negative whole numbers. Okay, so we have to get rid of this fraction. Does anyone remember what we do? Layla? Okay, that is if you're trying to find x. But there's a different way. We call them clearing fractions. Does anybody remember how to clear a fraction? That's what Layla was saying, but that's only if like you have 1/2 x equals 8 and you're trying to figure out x. Yes.
You would play what's
The denominator. Yes. Yes, exactly. You multiply every term on the inside by your 2, your denominator. Now, if there were more than one fraction, you would multiply it by your common denominator. So in this case, we're going to multiply everything by 2. Okay. So 2 times 1/2 is 1x, or just x. Okay. And we know that because here, this becomes a 1 and that becomes a 1. 1 times 1 is 1. Okay. And then 2 times y is 2y. And 2 times 5 is 10. And that now is in standard form. Your a term is positive. It's a positive 1, even though we don't see it. There are no common factors. Okay, there is a common factor between 2 and 10, it's 2, but not between 1, 2, and 10. There are no more fractions anymore, and both variable terms are on the left. Okay, so this is your answer right here. Okay, look at the next one, 4x plus 6y equals 12. The problem with this one is they all have a common factor. What is the common factor between 4, 6, and 12? 2. So what we're going to do is we're going to divide every term by 2, and it's like reducing fractions. We're simplifying the equation, okay? So 4x divided by 2 is 2x. 6y divided by 2 is 3y, and 12 divided by 2 is 6. And we have simplified it down to a standard form of an equation, and it meets all 4 requirements. Okay, the next one, negative 7x plus y equals 4. A is not positive. How are we going to make it positive? Yeah.
For the one,
Oh, this one.
yeah. Isn't it still? Have a common factor?
There is the only common factor between those is 1. So, and we don't count 1. When we say common factor, what we're talking about is you're going to reduce it to lowest terms. And you cannot divide 2 and 3 by a number, by the same number to get a whole number. Does that make sense? Okay, JG?
What if the constants after you divide them, what if they still have a common factor?
Like 2 and 6?
No, like if all of them have to divide.
Then that means you did
Yeah,
not
for
choose the
sure.
greatest common factor. Yeah, you have to choose the greatest common factor. That was a good question. All right, so what do we have to do to this one to make our A positive? Yeah, you can multiply everything by a -1, or you can divide everything by a -1. So I typically multiply everything by a -1. So -1 times -7 is a positive 7x. -1 times a 1y is a -1y. And -1 times 4 is a -4. You'll notice that there are negatives in the standard form of the equation. But A isn't. You only have to worry about A. Any other term can be negative, all right? And so both your variable terms are on the left. A is positive, there's no fractions or decimals, and there are no common factors, so this is our final answer.
Why can't 80?
It's just, that's the correct way to write standard form.
Um,
It's just one of those rules. Okay, let's go to page 3. We are going to now take our standard form of the equation and try to find intercepts. Now, we did all that, putting equations in correct standard form, but when it comes to finding intercepts, we do not need to do that, okay? So I'm going to show you the actual method of what we're doing, but then I'm going to give you a shortcut. And if you understand the shortcut, you can do the shortcut. So let's look at the steps first. It says, make sure the equations are in standard form. So example 1, is this in standard form? It's in the ax plus by equals c, so it is in standard form. To find the x-intercept, let y equal 0 and solve for x. So I want to find my x-intercept. So what this is saying is to let y equal 0 to find your x-intercept. So I'm going to substitute 0 in for y. Okay. And now I solve for x, and that will give me my x-intercept. So 14x, oops, plus 7 times 0 is 0 equals 28. And then we subtract 0 from both sides. And we get 14x equals 28. And then we're gonna divide both sides by 14. And x equals 2. And we properly write our x-intercept as 2, 0. And that's, I do want you to write your intercepts this way in an ordered pair.
If,
Oh, did it? Okay. Okay. So we made sure that the equation was in standard form, and then we found the x-intercept. Now we want to find the y-intercept. To find the y-intercept, you let x be 0 and solve for y. So now I'm going to substitute my 0 into x right here. And solve for y. So 14 times 0 is 0. And then I subtract 0 on both sides. And we get 7y equals 28. We divide by 7 on both sides, and y equals 4. And we write it as 0, 4. Okay. So now that we have our intercepts, we're going to plot them on the line and we're going to graph them. Okay, so I'm going to plot 2, 0. That's my x-intercept. And I'm going to plot 0, 4. That's my y-intercept. And then I am going to draw my line. Remember to put an arrow at the end of your line. That indicates that it goes on forever and ever. That's where I got our verse from. Okay, before I move on, does somebody see a shortcut way of doing this? And I'm just going to give you a little hint, the zeros. No? Okay, I will show you in the next one then. All right, let's go down to example 2. Our first step tells us we must put it in standard form, the equation. So we have to put this one in standard form. What are we going to do? Yes. Yeah, 6 has to stay over here, and that means that we're going to move the negative 3y over. So I'm going to add 3y to both sides. Now remember, when I add 3y to the left, it comes after the x term. Okay. So I now have 3y. Oops, I just told you what to do, and I was about to do the wrong thing. We have x plus 3y equals 6. And I'm going to rewrite this again for my other one. Okay. And now we need to find our intercepts. So I want to go back up to this one and just kind of explain the shortcut before I do it. Notice here that when we're finding the x-intercept, the y is 0. Whatever you multiply the y by, it's always going to be 0. So you can pretty much skip these 2 steps. It's like you're doing extra work when you already know this is going to be 0. And anytime you subtract or add 0 to a number, you're going to get that same number. That's the identity property. So if you look down here, if I want to find the x-intercept, I just set my x term. We know that 3y is going to cancel out when you multiply it by 0, right? So we could just cancel that out. And we get x equals 6. And it just so happens that x is by itself, so we don't have to divide anything. And so this ordered pair is 6, 0. Let me show you with the other one, because the other one is a little different. So now I want to find my y-intercept. So I have to plug 0 in where the x is here. Well, if x is 0, and I subtract it from both sides, I'm still gonna get 3y equals 6. So I could just cancel that out and that could be my first step. So then I just set this up as 3y equals 6. But then I do need to divide by 3 on both sides. And here y equals 2. And I write my ordered pair as 0, 2. So that's just a shortcut, so you don't have to do some unneeded work. Are there any questions on how or why I did that? Okay, and you can use either way. Just make sure that you're showing your work, because I know a lot of you are going to be able to do this in your head. But I still need to see your steps. So let's go ahead and graph these. My x-intercept is at 6. My y-intercept is at +2. And then I graph my line. Okay. I would like for you to try example 3 on your own. Remember, you have to rearrange it first. And so I'm going to pause the video while you work on this, and then we come back, we'll go over the answer. So go ahead and check your answer, see if you got it right. And if you didn't, check the work and see where you may have made a mistake. Are there any questions about this? Okay. Let's go ahead and go to the next page, page 3. No, page 4. So page 4 is more practice. And based what I see on here, you should be able to do 4, 5, and 6 on your own. Not 6?
Like a fraction.
Oh, okay. All right, so I can show you that one. Why don't you work on 4 and 5 with a partner? And then check with each other. And then we'll come back and look at these answers, and then I'll do 6 and 7 with you. Okay. All right, so I'm going to pause the video while you try these on your own. Okay, go ahead and check to make sure your intercepts and your graphs are correct. Check my work as well. You never know when I'm going to make a mistake. Any questions on these? Okay. Hold on a second. Okay, so we're going to do examples 6 and 7. These involve fractions, but no worries. Okay, so for example 6, we're going to go ahead. It's already in standard form, so we're going to set these up and find the x and y intercepts. And I think some of you have already done this. And by this point, you don't really need to watch me do it because you've done so many. Okay, so it's 7/2 for your x-intercept. And for your y-intercept, it's -7/3. Okay, now, the thing about graphing fractions is that you're not going to have the most accurate graph unless you're doing it digitally on a computer or a calculator. So what we do is we estimate when we hand graph. And the easiest way to do that would be to turn your improper fractions into mixed numbers. Now, when you write your ordered pair, write them as improper fractions. But what I can do here is I can turn 7/2 into a mixed number. Okay, so when you turn it into a mixed number, just in case you don't know, 7 divided by 2 is 3 and something, right? So it's 3 and 1/2. So 2 times 3 is 6, 6 plus 1 is 7, and that would be 7/2. And then negative 7/3 would be negative 2 and 1/3. Are there any questions on how I got the mixed numbers? Okay, basically you're just dividing these two. All right, so now when I graph them, I'm gonna graph for my x-intercept 3 and a little bit. Because it's 3.5, so I'm gonna graph between 3 and 4. So I'm gonna go over 3 and then 1/2 or a little bit more. For negative 2 and 1/3, I'm gonna go down to negative 2 and then it's a little bit more. And I'm just gonna graph a point between negative 2 and 3. And that's how we are gonna graph fractions without a graphing calculator, okay? So are there any questions about that? Do I need to zoom it in? No? Okay. All right, I'm gonna go ahead. Is anyone still working on this one? Okay, I'm gonna pause for just a minute. Number 7. Okay, remember what rule in turning an equation into standard form do we need to use and apply to this equation in example 7? What's wrong with it? Yeah, there's fractions. We need to get rid of the fractions. Now remember, sometimes I said there's going to be multiple fractions. So in this case, you have to find a common factor or common denominator and multiply all the terms by that number. So in this case, it's 6. So I'm going to multiply this by 6, this one by 6, and this one by 6. Okay. Now, when I do this, I'm going to cross simplify my 3 and my 6. And I end up with 2. And 2 times 2x is 4x. And then I cross simplify my 6 and my 2. And I get 3. And negative 3 times 1y is negative 3y. And then 6 times 4 is 24. So we've just gotten rid of the fractions and now we can find our x and y intercepts. So I'm going to write this twice for both intercepts. And I'm going to go ahead and pause the video while you find the intercepts for this equation. Okay, go ahead and check your graph on this one and your intercepts. Okay. Any questions? Okay. Let's go ahead and go to page 5. On page 5, there are 2, and I think you get the graphing. So what we're going to do on these 2 problems is instead, we're not going to graph them, okay? All we're going to do is we're going to turn them into standard form, okay? Because I want you to practice that, and then we'll move on to the back page. So I want you to take A, 2/5 x plus 3/4 y equals 3. And I want you to turn that one into standard form based on what we just did. Okay, now, does anyone know what we're going to have to do to B to turn that into standard form because we can't have decimals? Yes.
Multiply out.
And Mason, what will we need to multiply these by?
4.
Oh, this one right here or the decimals?
Oh. But for A, it would be 20.
Yes, for A, it would be 20, right? And then JG, what about B here? 100, because 100 will move your decimal out of the 0.75. Just be careful because you have to move your decimal in the 0.5 twice and in your 3 twice. And remember, The decimal in 3 is at the end. Okay, so, oops, so go ahead and rewrite both of these into standard form. Okay, and I'm gonna pause the video while we do this. So this is example 8. And for the people watching on the video, I didn't say to simplify it or put it in correct standard form. So if you did it, for A, you'll get this, and for B, you might get the 75x minus 50y equals 300. And that's fine also when you're finding intercepts. Okay, and then example 9. If you didn't change your A to positive, you'll get negative 4x plus y equals 8. If you did, you get 4x minus y equals negative 8. And the same for letter B. Yes.
For number 8.
Mhm.
Isn't it 15? Yeah, is it decimal over? Oh. Isn't it 15? Because it's 4 and then 5 times 3.
Okay, hold on a second. Let me. Okay, this one should be 15. You were right. I'm sorry about that. Okay. Any questions? Somebody asked me to move it up. Is that correct?
Yes.
Okay, so here is example 9. Okay. Go ahead and go to page 6, the last page. There's a lot on here. This page is a review, I think, of what we've already done or what you may have done in pre-algebra. What happens when you don't really have an equation? You don't have a slope intercept, or, well, these are equations. What happens if you don't have a slope intercept or a standard form? How do you graph these? Well, these are basically your intercepts. Okay, so you can look at this one as 7, 0, and you can look at this one as 0, -8, and you just graph them. So you're going to plot 7, 0 here. The thing is that they're individual equations. Anytime you have an equation that says x equals 7 by itself and you did not find the intercept, you are going to draw a line through the x-axis. Okay, so whenever you get an equation that says x equals that number, you plot a point on the x-axis at that number and you draw a line. What is this slope right here? Yes, this is undefined. Okay, anytime that you have y equals, you're gonna plot this point on the y-intercept at -8. And you are going to draw a horizontal line through the y-axis at -8. You will not, whenever you have these two like this, you will not connect the two intercepts. It's only if you're solving for intercepts, and we did not solve for the intercepts here. What is the slope of a horizontal line? Yep, here slope equals 0. Okay. And it might help to write 0 slope here. Oops, I don't know why I put a P. And undefined slope here. Okay. All right, so let's look at example 11. X equals -3. I'm going to plot a point at -3 on the x-axis. And then I'm going to draw a line through -3. Now, some students are going to want to draw their line along the y-axis. I'm going to tell you this, never draw a line over the axis. If you are doing that, then you're graphing it wrong. So if you start to do this along the axis, go, oh, I need to do it this way. because I'm drawing my line through the X. Okay,
Minus 3.0.
You graphed the wrong way.
oh my goodness, I did, thank you. I graphed it on the Y instead of the X. Yes, -3.0. Oops. Okay. And draw over there. And then I'll draw my Y. So my Y is at 5. And I'm going to draw a line through the Y axis at 5. Don't forget your arrow. Okay. Questions about drawing horizontal and vertical lines? Okay, let's move down here. Let's look at this graph right here. We're just going to identify the intercepts. So what is the x-intercept in this graph? 3. So we're going to write it as 3, 0. And what is the y-intercept? -4. So we're going to write it as 0, -4. But what happens when you have an undefined slope here? What is our x-intercept? 8. So it's at 8, 0. Do we have a y-intercept? No, so none. And the equation for this line is x equals 8. I want you to write that. Okay. And then that way we know how that equation is written. And then we don't have an x-intercept on this one, so we write none, but we do have a y-intercept of 0, 3. And so the equation of this line is y equals 3. All right, so that concludes our lesson for 3.2.